Alright, here we go. Last one. Last lesson for chapter 8. Well, it's not even really a lesson. It's not in your book. Remember, I'm going to give you a worksheet that deals with this. Alright, so this is just reviewing the areas of triangles and quadrilaterals. I throw triangles in there. We're going to use them just a tiny bit, but mainly we're going to be dealing with quadrilaterals in this one. Alright, so a couple things we need to know. So, I'm going to give you formulas. I'll kind of just reveal all those. We'll talk through them, and then some key thoughts over there on the right side that we'll talk about here in a second. Let me get this up and out of the way here. Alright, so area formulas. So area of a triangle, base times height divided by 2. Okay, and you should know that one from a long time ago. Area of a parallelogram, base times height. Area of a rectangle, base times height, or length times width. We usually use this kind of cursive L. Let me zoom in a little bit so you can see these a little bit better. Alright, that would be the other way. Okay, so you can kind of see how that's a cursive L there. Alright, and the reason we use a cursive L most of the time when we're dealing with rectangle is because we don't want you to think it's a 1. So if we just put like a lowercase L, it kind of looks exactly like a 1. Alright, so area of a rhombus, base times height, or D1 times D2 or 2. And most of the time we use this one. You can use base and height on a rhombus, but a lot of times we don't really know the height. We could figure it out maybe, but D1 times D2 is over 2 is pretty easy to use. Area of a square, base times height, or D1 times D2 over 2, or you can use side squared. And really, base times height and side squared are the same thing because the sides are equal. And I guess we even could have thrown length times width in here, but alright. Area of any trapezoid. You add the bases, you multiply by the height, and you divide by 2. Okay, and then finally a kite, D1 times D2 over 2. And really that D1 times D2 over 2 formula right here, it works for any shape that has, any quadrilateral that has perpendicular diagonals. You could actually have a trapezium that's not a kite, but still somehow does have perpendicular diagonals, and you could use that to find the area of that shape. Okay, so key thoughts. Alright, so let's talk key thoughts. Let me move the camera over here so you can see this. Actually, maybe I'll just zoom out a little bit. Hopefully you can still see it all. Okay, so here we go. Some key thoughts about area. So B stands for base. Okay, and I was saying that as we went through anyways. Hopefully you remember that. B stands for base. H stands for height. D stands for diagonal. W for width. L for length. S for side. Alright. Base and height must meet at a right angle. Anytime you're talking about base and height, if you're not dealing with two things that meet at a right angle, you have not found the base and the height. Formula that uses diagonals only works when the diagonals are perpendicular. So just make sure you're aware of all that. So this is all review. You should already have most of this down in your other section. If you don't for some reason, get it in the other section of your sheet. All right, let's do some examples. All right, so I got a bunch of shapes here, and my camera is struggling to focus. Work on that a little bit. Zoom out a tiny bit more. Alright, here we go. So I want you to find the area of these shapes. Alright, so I'm just going to give you 3 of them. Okay, so go ahead, copy them down real quick if you need to, and solve those areas, and then come back in a minute or so, 2 minutes, however long it takes you, and we'll do them together real quick. Okay, pause, solve. Alright, hopefully you're done by now. If you haven't done them, seriously, stop the video, do the work. Okay, I'm going to switch the camera down to my paper so you can see what's going on here, okay? So hopefully I can do this without too much problem. Alright, you guys ready? So that first one, we had a rectangle. That's what it told us, and it was 8 by 5. Real quick sketch, 8 by 5. Alright, can you see that alright? Okay. Zoom in a little bit. Alright, 8 by 5. Okay, that's pretty easy. Well, rectangle length times width, 8 times 5 is 40. Stick our label on. They didn't give us labels, so this will be units squared. That was simple. Alright, you guys should be able to do that real easy. Okay, next one is parallelogram. So they had a 9 up here, a 6 over here, dotted line with a little mark down here at the bottom with 4. Alright, so what's our formula for parallelogram? Base times height. Base and height must meet at a right angle. Well, here's my right angle. So that 4 is meeting, well, this. Well, what's this? Hey, opposite sides of a parallelogram are congruent, so it must be a 9. So 4 times 9 is 36 units squared. That's pretty easy. Why is the 6 here? Confuse you. That's all it's there for. Don't let it. Be smarter than the question. Okay? Alright, let's do this one right here. Rhombus. I don't have this drawn the way they have it very well, but we'll go with it. Okay, it looked kind of something like that. Alright, so what do we got? We got a diagonal here, diagonal here. They told me this was 7. Got my right angle, this was 5. Okay, diagonals have to bisect each other, so that's also 5. That's another 7. That total diagonal is 10. The other total diagonal is 14. Area of rhombus, diagonal 1 times diagonal 2 over 2. 140 over 2 equals 70. Once again, units squared. Okay, so hopefully all that looks pretty familiar, pretty easy stuff to do. Okay, let's go back up to the computer. Gonna have to zoom out a little bit. And let's look at the next 3. Oh, wrong direction. Here we go. Okay. Alright, next 3. So what do we got? We have 3 more shapes. We got a triangle there in the bottom left. Got an isosceles trapezoid and a kite. Okay, so go ahead and copy those down and find their areas real quick and then come back. Pause the video, do that work, come back real quick. Alrighty, you should have paused that by now. You should have all copied all those down. If you haven't copied them down and done them, do them real fast. I'm going to switch back to my paper. We're going to do that first one, which we were told was a triangle. Okay, triangle. Now this had lots of lines going on. Got a dotted line out here, a little dotted line, then went back to solid. Got a slant here, got a right angle mark. It's not in focus, or actually ain't even in the paper. All right, so I got a 3 here, I got a 4 here. This says 5. You shouldn't need to be told that's 5 because that's a Pythagorean triple. We got an 8, we got a 10. All right, well, what in the world? All right, base times height divided by 2. Remember, base times height divided by 2. Base and height have to meet at a right angle. Now we got to make a little extra information for this. You can extend the base so that it meets the height at a right angle. Now, what that means is the 8 extended will eventually meet the 4 at a right angle. That doesn't mean we use 11 for our base. If I was using 11 for my base, I'd be finding this really big triangle. That whole thing is 11 and 4. And that's not what we want. We only want this. So I don't want 11 by 4. I just want 8. That's the base of the triangle itself. The base is going to be a side of the triangle. And then the height is this thing over here. So 8 times 4 over 2. 32 over 2, which is 16. Once again, units squared. Remember, it could be inches squared, feet squared, whatever. All right, let's go to that next one. Isosceles trapezoid. So we got a 13, right angle, 8, 19. Now we could figure out isosceles. This would have to be 13, 19 minus 13, 6, split evenly, 3 and 3. We don't really have to do that, but that is true. Okay, but we don't even need the 3 and the 13 and the 3 in order to solve this. So what's our formula? Base 1 plus base 2 times height over 2. Okay, so that's what it looks like. So base 1 was 13 plus 19 times 8 over 2. If you switch the order of the addition up, no big deal. 13 plus 19 is 32. If you do 19 plus 13, you're still going to get 32 times 8 over 2. 32 times 8 is 256 over 2, which is 128 units squared. Alright, pretty simple. Alright, let's try this last one. Alright, we had a kite. So, boom, boom. Alright, longer sides. Some dotted lines here, dotted lines here. We know that kite's diagonals meet at a right angle. I didn't draw that on the computer, but you should already know that. This is 3 and 4 and 9. Now, I should be able to get away without giving you this 3 if I said like this was 5 and this wasn't here. Pythagorean theorem, solve for the 3. Okay, same thing, if I gave you a number here, you should be able to solve for this side, or this part of the diagonal. Okay, so just be aware Pythagorean theorem could show up quite a bit in these things that have right angles. Alright, what's our formula? D1 times D2 over 2. Now, just so you're aware, I get lots of people get this and this confused. They want to multiply here, or they want to add here. If you add here, you haven't found area. Area involves at least some kind of multiplication. And it's because of the labels. Area is units squared or feet squared. Well, the way I get squared is by multiplying things. So if you put addition here, you haven't multiplied anything, you haven't found area. Over here, if you multiply here and then multiply here again, let's say it's inches. Inches times inches would be inches cubed. That's not area either. Okay, so you can't multiply here. It's got to be addition. All right, so just make sure you don't confuse these formulas. Okay, back to this one. Diagonal 1. This whole diagonal right here. We know that one diagonal in a kite is bisected, and it's definitely not this one because it's a 3 and a 9. So it must be a 4 and a 4, so that's 8. 3 plus 9. I get people every now and then, some reason they want to put 27 down for this diagonal. Add, you get 12. Divide by 2. 96 divided by 2, which is 48 units squared. Okay? Alright, pretty simple there. Okay, back up to the computer, and we're going to show you slightly different version of some area stuff. Alright, so I'll zoom back out, and that'd be the wrong one. One of these days I'm going to figure this camera out. Alright, so, alright. Here we go, a little bit more with area. Alright, so copy these down. Next page here, let me get to it. Alright, this time I'm going to give you the area of the shapes, and you got to solve for x. Okay, so two of them here to start with. Okay, so go ahead and copy those down. If you can't see this right here, that's the x, a 10 and a 14, and the area is 84. Over here we have a 6 and an x and a 54. Okay, so 10 and x and 14, 84, and then 6 and x and 54. Okay, so copy those down, stop, pause the video, solve them real quick, and then come back. Alright, you should have already done that, so let's take a look at this trapezoid. Alright, so we had a 10, we had our dotted line, perpendicular x, 14. Okay, our formula, remember, is base 1 plus base 2 times height over 2 equals the area, which is 84. I'm going to put that over 1. I'm going to cross multiply. 84 times 2 is 168. 10 plus 14 is 24 times the x times the 1 is just 24x. Divide both sides by 24 and I get x equals 7. Now this is not units. Remember, it was 84 square feet, so this must be feet. Okay? So all you're doing is setting up your formula, equals the answer, solve, do some kind of algebra. Okay, let's look at this one. The parallelogram is a really easy one. Okay, so I got this. I told you that this was 6 and this was x, and the area was 54. Base times height equals area. Divide 6. 6x equals 9. It said it was 54 inches squared, so this has to be inches. Okay, it's a pretty simple one. All right, back up to the computer, 2 more examples, and we got one final example, and we're done. All right, so next 2 examples. All right, copy these 2 down. All right, we got a rhombus right here. If you can't see that, that's an 8 and an x and an 80. The answer is not 10. I'm going to tell you that right now. Okay, 8, x, 80. Over here, x. It's a square. Area is 50. So rhombus, 8x, 80, x, 50. Solve. Pause, do it. Come back here in a minute or 2. I'll show you how it's done. All right. Should have already done those. Okay, so you got that rhombus figured out. You hopefully did not get 10. If you got 10, you got it wrong. All right, let's take a look at it. So we got our rhombus here. We got our diagonals. This is 8 perpendicular, x area equals 80. Okay, zoom in a little bit so you can see that better. Which way? Yeah, that way. All right, so diagonal 1, the whole diagonal, remember it's bisected in any kind of parallelogram, so 16 times diagonal 2, which is x plus x. X plus x is 2x over 2 equals area. I'm going to put this over 1, cross multiply. 16 times 2 is 32x. 80 times 2 is 160. Divide by 32, divide by 32, x equals 5. It said it was meters squared, so meters. Now I've seen some people do this one slightly different ways, so let me show you another way you could do it. Alright, so diagonal 1, 16 times diagonal number 2, which we don't know, and they just call the whole diagonal d. Over 2 equals 80, which is over 1. Cross multiply 16d equals 160, divide by 16, so d equals 10. But d, in that case, is this whole diagonal. And so just to solve for x, I have to cut it in half, so that takes me right back to the 5 that we had down here the first time. Either way is acceptable, as long as you show proper work. Alright, last one, a square. Alright, it said this was x and the area was 50. Okay. Alright, well, how do we find the area of a square? Length times width, base times height, x squared. Side squared, so x squared equals 50. Square root. No decimals. I don't want 7.07 for an answer. If you give me 7.07, I'm going to mark it wrong unless I specifically tell you to round. So break it down. 10 times 5, 2 times 5, pairs. Pairs go outside, singles stay inside. 5 root 2. It said square yards, so this must be yards. Alright, last one. Last question for chapter 8. You guys are thrilled about that, right? Alright, now, this one's tougher. Okay, here we go. Copy it down, try to solve it. It's a rhombus, okay? Dealing with a rhombus. And this is what it looks like. I'm going to zoom in on it a little bit for you. Alright, in the center here, and zoom in. Alrighty, here we go. This side of the rhombus is 16 now. We know a rhombus has all sides are 16. 46 degrees is the whole angle here. Okay, pause, try to solve. This one's tougher. Don't round early. Okay, take a couple minutes and solve it. I'm going to give you time to pause, then I'll do this problem. Alright, so you should have tried this already. Hopefully you figured out it's going to require a little trigonometry. Okay, so got this diagonal, got my big 46 degree angle, and I got my 16 out here. We know our formula is diagonal number 1, this whole thing, diagonal number 2, this whole thing, times 2, and then divided by 2. So what I'm going to do is I'm going to draw just this triangle. Okay, I'm going to draw that down here so I can work with it a little bit. Okay, so this is a right angle. Remember, the diagonals of a rhombus are perpendicular to each other. Okay, so that's this same right angle right here. This is 16. This is 23 degrees. Oh, Mr. Oates, hold on. Where did that 23 degrees come from? Diagonals of a rhombus, what do they do to the angles? They bisect it, they cut it in half. 46 cut in half is 23. Okay, I'm going to call this x and I'm going to call this y. And we're going to solve for them. Alright, so here we go. How do we solve for x? That's opposite. That's hypotenuse. Opposite hypotenuse, SOHCAHTOA, sine. Sine of 23 degrees over 1 equals opposite x over hypotenuse 16. Cross multiply. X equals 16 times the sine of 23 degrees. I am not going to type that into my calculator and round it off. I'm going to show you y here in just a little bit. Okay, let's solve for y. What is this? This is adjacent. This is hypotenuse. We're using cosine. Cosine 23 degrees over 1 equals adjacent over hypotenuse. Cross multiply, y equals 16 times the cosine of 23 degrees. Okay, let's go back up and look at our original picture. That x was right here. That y was right here. That x is half of the diagonal. That y is half of the diagonal. So this is only half of diagonal 1. And this is only half of diagonal 2. So let's go to our formula now. Diagonal 1 times diagonal 2 over 2. So diagonal 1 is 2 times 16 times the sine of 23 degrees. Times 2 times 16 times the cosine of 23 degrees. Divided by 2. Now you can simplify this a little bit, or you can just type it all into your calculator just like that. But I'll show you a little simplifying if you want to. 2 times 16 is 32. 32 times 2 is 64. 64 times 16 is 1024. So 1024 times the sine of 23 degrees times the cosine of 23 degrees over 2. Well, I can reduce 512 times the sine of 23 degrees times the cosine of 23 degrees. All right, let's type it in our calculator. I'm going to type it in this way and show you how they both give us the same answer. At least I sure hope they give us the same answer. All right, so here we go. Typing it in the long way first, that top way right there. 2 times 16 times the sine of 23. If you don't close this parenthesis, it's going to cause problems though. Okay, times 2 times 16 times the cosine of 23. Close the parenthesis, you're going to have problems. Divided by 2. 184.1509889 and a bunch of other decimals that my calculator is not going to tell me. All right, so let's look at doing it this kind of somewhat simplified way. 512 times the sine of 23, close the parenthesis, times the cosine of 23 degrees, close the parenthesis. Same exact answer. 184.15. Okay, square units. Now I'm going to show you real quick why we don't round early. So if I went back over here to this x equals 16 times the sine of 23, and I just type in 16 times the sine of 23 degrees, I get 6.25169, and I round that off to maybe 2 decimals, 6.25. Okay, and then I type in this 16 times the cosine of 23. And I round that off, okay, to 14.73. Okay, 14.73. Now, if I take diagonal number 1, which is 2 times this, so 2 times 6.25, times diagonal number 2, which is 2 times this, 2 times 14.73, over 2. And I'm going to type that into my calculator. 2 times 6.25 times 2 times 14.73 divided by 2, enter. 184.125, which would round to 184.13 if we wanted to round it off. Do you see the problem? That's the better answer. That's the worse answer. All right? Don't round early. You'll get it marked wrong. Chapter 8, we're done. Be ready for quizzes and tests and get your homework finished. All right. Hopefully you don't have any questions. If you do, ask in class. All right. We'll see you guys in next class. All right.